Hey monkeys, it's Jim from Small Time Outlaws bringing you the fourth video in the simple game programming tutorial series. In this video we're actually going to create the blocks for our player to land on and a function that's going to randomly and automatically generate the strips across the screen for our floors. So starting out in the following module, we're going to create a couple more constants. What these constants are going to be for is to specify the width and height of all of our blocks, or in this case tiles. And like I said, these we're going to make them 48 by 48. And so the way this is going to work is these strips of floors are going to be sized automatically, or the floors are going to be sized automatically based on the width of our tiles and the width of the screen. So right now I'm just doing 48 by 48, and then I'm going to tell our little game what size the screen is. So we'll go with 640 and the screen height is 480. And then eventually, once we're done with this, you'll be able to come in here and, if you don't like if you think these tiles are too big or too small, you can change them whatever size, and it'll automatically adjust for that size, the new size. Now down at the bottom, let's go ahead and create a class for the blocks, and we're going to call it block. And these blocks are going to have a position in our map, and we'll create a constructor, and this is going to take the block's position and set it. And then all they're going to have is just a draw. So these blocks are going to be stationary. They're not going to move once they're set. So they don't need an update or anything like that. And for now, just temporarily, we're just going to create some simple rectangles. So we're going to set the color, and we're going to have a nice border. So I'm going to create one big rectangle and one small rectangle inside it. So it creates a border. And just like with the player, temporarily we have to offset the rectangle drawing so it's centered on the position. So in this case, we're going to subtract the tile width that we set, divided by 2, and then do the same with the y, with the tile height divided by 2. So that's going to center our rectangle on that position, and then we're going to give the tile width and tile height. And now let's go ahead and do our, let's like a darker color, so this is going to be a darker gray. And then we're going to draw, I'll just go ahead and copy this, paste it. So let's draw another rectangle on top of this one, but we want it to be a little bit smaller. So we're going to come in here, and let's say we want a 4-inch or 4 pixel border. So we'll subtract 8 from the width, or actually this will be an 8 pixel border, I think. Whatever. And then come in here and change all of our sizes, our sizes to be subtracted by 8. So it's just an 8 pixel smaller rectangle. And like I said, if you think this is ugly, which it is, don't worry about it, because we're going to be switching this out with an actual image later on. Now let's go back to our main class, and we're going to set up a couple fields for our map. So the first one is going to be the map width, and this is going to be the number of tiles across that our map is. And this is something we're going to calculate automatically based on the size of the screen and the size of the tiles. And then the same with this one, it's called map offset. And this is going to be make it a float. And this is going to be the offset from on the sides of the screen. Because, like if you see right now, I've got my screen width is 640, but my tile width is 48. And if you divide 640 by 48, you get 13.3, I think, or something like that. So it's not a whole number. So we're actually going to have 13 tiles across with our map width, but then we are going to have those gaps, and we want that gap to be even on both sides to compensate, because we can't have a third of a tile. We don't want that. So this offset is just going to tell it, it's just going to compensate for that extra remainder when we divide that. And you'll kind of see what I'm talking about once we get this going. So now inside our onCreate, we're going to go ahead and calculate this. First, we're going to go with the map width is the screen width divided by tile width. And you notice these are all integers, and so when we do this division, yeah, it's going to have a remainder. It's going to be like 13.3 or whatever, but it's going to be, the actual value is going to have that decimal portion chopped off, so it's going to be just a 13 whole number. Then our map offset we're going to calculate using the screen width again. This time we're going to use the mod operator with the tile width, and that's going to give us the remainder of this division, which will give us the excess. But then we want that excess to be distributed evenly on both sides of the map, so the whole map is centered. So we're going to divide that by 2. And now let's actually go back. I forgot to add one more field. This is actually be our blocks, and it's going to be a list of the block type that we created. And we initialize it here with a new block list. It's going to be empty. So basically how it's going to work is, as we generate these blocks, we're just going to add them to this blocks list, and then we're going to loop through that block list to when we render them. So that's really all this list is for, is just to render the blocks on the screen at their positions. So now let's go down underneath our onRender method. We're going to add another method to our, make sure it's inside this falling game class. We're going to call this generate floor. And what this generate floor is going to take is the number for the row in the row we want to put the floor on in our map. So we need to think about our map as being tiles that are 48 by 48 in size. The whole map right now with this game is going to be 13 across, and then the rows going down, they're all going to be 48 pixels in height each one, but then that's going to be able to go forever. But so we're going to pass in wherever we want to stick these blocks in our map. So right now it's called float, and it's going to be an int. And so what this generate floor is actually going to do is going to generate a floor going across with holes in it placed randomly. But for right now, I'm just going to make it so it does a full floor 13 tiles wide, so you can kind of get a visualization of exactly what's going on here. So this is going to be kind of temporary code here. So I'm just going to create a little for loop that goes from 0 up until the map width. So it's going to fill each tile. Oops. And it's going to add, we're going to add a block to our blocks list. And inside here, we're going to just create a new block. And if you remember, our block takes just an X and a Y position. And this X and Y position is actually going to be the pixel position and not the actual tile position, if that makes sense. So we're going to pass in as the X is the map offset plus the tile width divided by 2. And what this is going to do is going to offset, it's going to give us our gap on the left. It's just going to be black. And then we need to center the tile inside its tile position. So we're going to do that, we need to add half of the tile width to center it in the X direction. And then we're going to add our X, our tile X position times the tile width. Whoops. So this will place each tile offset by the tile width in a row. So you can kind of think of this X as a column in our map, and our map is 13 columns wide. And so for each one starting at 0, it's going to be offset by this much, and then offset, the first one's not going to have this, it's going to be 0 times tile width is 0. The next one's going to be 1 times tile width, so that's going to be 48 shifted over to the right. The next one's going to be 2 times tile width, which will be 96, shifted over to the right, and then so on, so to fill out our row. And then for the tile height, it's a little bit simpler. We're going to say 0 is just the top of our screen. And so we're just going to say, starting at the row, which will start from 0 and then go on till whatever, it doesn't matter. So row times tile height. So that'll give us a 0 for our first row, or if we pass in a 0 here, we'll get 0 as our Y position. So we want to add, once again, the tile height divided by 2 to center our tile inside that row. So that will handle that. And let's go ahead and close off this generate floors method, and then we're going to go back into our onRender, and we want these blocks to shift with the camera, and they're going to stay in place. So you see, as our camera moves down, the blocks are actually going to move up, and that's kind of the effect we're trying to create in this game. So I'm going to put it before the player draw. So we're going to create a for loop, or for each in loop with our block list. So we'll say for local block assign each in blocks, and we'll just call block.draw. And let's go, and that's going to be temporary, we're just going to create a row real fast, and we'll put this, generate floor, and we don't want it to be the top because that's where our player's at, so I'm just going to put it at like, we'll put it in the 3rd row in our map. Now when we run this, we get an error because I forgot to add a parentheses here. And now let's try to run it again. And there you can see this floor is in the 3rd row. So we have 0, 1, well guys, technically the 4th row, and you can see I'm pressing R a bunch to keep it up here. So we have the row 0. I should really set it so we can pause this. So I'm going to do that real fast. So I'm going to change our camera to not move, not false, set it to 0, and run this again. Alright, so now you can see we have 0, 1, 2, 3, so it's actually the 4th row, but its index, or its row number is 3. And then you can see our map, our offset value here is on both sides to keep a black region on each side of the screen. So our map is centered no matter what size our tiles are, and no matter what size our screen is. And now let's go back to our generate floor method, and we can scoot this down. We'll change this for loop to be more appropriate for it. So what we're going to do here is we're actually going to set it up so we have random holes placed in the floor. And to do that, starting out, we're going to create a local variable called numHoles, and we're going to say we got a random value. I'll say at a minimum we want 3 holes, and at a max we want 7. So let's actually be 7 because 8 is not included in this random value. And then once it gets assigned to numHoles, it's going to be cast as an integer, and then the decimal value is going to get chopped off. And now let's create, what we're going to actually do here is we're creating a stack of integers. So we're going to create an int stack, and this is a class that comes with Monkey. And we're going to just create a new instance of our int stack. And now we're going to initialize this stack. And I'm going to start commenting this just so we can, just in case you come back to it later on and you're like, what was I doing in that generate floor level, or that generate floor method? So we're going to say what we want to do now is we want to initialize our stack with an index number for each column in our map. So what we'll do, we're just going to give it, pretty much we're just going to give it 0 up to map width, not including map width. And we're going to push that into our stack. So to do that, create a local variable I, and let's go to 0 until map width. Whoops. and we're going to push this into our stack using the stack's push method, and we're going to push that number I. So once it's done, it's going to have, our stack is just going to be filled with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then what we're going to do is we're going to loop, once again, we use this I variable again, it's fine. And we're going to go for each hole, we're going to take out a random item in our stack. And basically what this is doing is guaranteeing that we have at least 3 to 7 holes. So otherwise, if you just said randomly, okay, for the first one I want it to be a 50-50 chance, and if you did a 50-50 chance all the way across your floor, it's very slim, but there's a possibility you'll get no floor at all, or you'll get a completely solid floor and the player won't be able to move through it at all. So what we're doing is just guaranteeing that we have at least 3 to 7 holes. So we're going to take out an index position for our floor from this stack. So it should make more sense as we go along. So I'm going to comment here and say what we're doing. We're going to pick a random spot in our index stack and delete it, thus shortening our stack. So we're going to create a local and call it the remove index, and it's going to be a random number based on the length of our current stack. So it's going to pick a number between 0 and the length of the stack -1, because it's not going to include this actual number. Put it in there, and then we're going to remove that position from the stack. And then go on to the next hole. So let's say, just so you can kind of visualize it here. So let's say we want to go through, want to take out 3 holes. So right now what we have is, okay, I don't have to comment. So right now what we have is in our stack is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So let's say on the first hole we want to take out, our index stack length is at its max. So its length is actually 13. So it's going to give us a random number between 0 and 13, but not including 13, so 0 and 12. So we're going to remove an item from our stack based on that random index we get. So let's say the first time we go through we get 7. So it's going to go through, it's going to take out index 7, which would be the actual 7. So now what we're left with is this index stack of length, it's actually length 12 now with that 7 taken out. So the next time we go through, because we want 3 holes, so on our second hole, it's going to be a random number between 0 and 12, or 0 and 11. And so let's say this time it says, okay, I want to take, it gives me 1. So we take out 1, and now we have an index stack of length 11 with that 1 taken out. So the next time it goes through, it says, okay, we get 10 this time. Now we're done. So what we're left with is 0, 2, 3, 4, 5. And so that's how our map is going to look. That's how this floor is going to look. The first one's going to be there, and the second row or the second column is going to be empty. And then the third, fourth, fifth, sixth, and seventh columns or spots are all going to have tiles. And then the next one's going to be empty. Then and so on. I hope all that made sense. So now down here, instead of going all the way across our map and just putting them in, we're going to go through our index stack and then use the values inside that index stack to determine which column has a block in it. So now we're going to, let's say X, and we're going to assign it to each in our index stack. So you know it's not going to be the index position of the stack, it's actually going to be the value stored inside the index stack. So when we take that and store that into X, we're going to have those gaps. So now when I run this, let's add a couple more floors to generate, and at different values. So I'll say 3 of them, and then this one's going to be 8 down. So now when we run this, as you can see, we've got gaps in our floors. And that's going to do it for this video. So in the next one, we're actually going to extend our little floor generator to continue to generate floors based on where the camera is. So as the camera goes down, it's going to add floor, and it's going to keep adding floors for as long as the player is alive. It's going to add floors, and also once it goes above the camera, it's going to delete that floor because we don't want to bother with looping through it anymore. So join me for that one. If you have any questions, you can email me at jim@smalltimeoutlaws.com or leave some comments down below.